Hey guys, welcome to Math 8. We are doing the notes for section 2.5, which means chapter 2, section 5. It is the last notes from chapter 2. So here we go. You can see that the notes today are on writing algebraic expressions, something we've already done practice on a little bit. I'll show you in a second on Delta Math. Generally, this is not too hard for people, but it is the beginning of algebra, right? Algebra is the use of variables. And today we're going to start having variables represent actual amounts. So let's look at this. I claim that many, if not all, real-world situations can be modeled using mathematical equations. And often we want to be able to do this, represent these real values by using an algebraic expression. And that's what we're going to look at here. These are the basic rules right here, these two steps right here. You let a variable, traditionally we like to use x, but you can use any variable you want on paper. A lot of people like to use a variable that maybe stands for something like h for height, something like that. I typically use x to represent some unknown amount. That unknown amount needs to be a value, like a number. We probably would not have our variable represent somebody's hair color because that's not a number, right? All right, once you have written your variable, you use that same variable in an expression to represent other unknown amounts based on how it compares. I ran out of space here, but to them. Based on how it compares to them. I'll show you what I mean here in just a second. All right, I'll refer to these as I do some examples. First of all, this is not on your notes, but I just wanted to show you this. On Delta Math, we have already done, I think, a couple assignments on a topic called words to expressions. It had problems that look like this. Write an algebraic expression where a number is the letter x. And so they gave you examples like 4 less than a number. Let's see, less than, that means subtraction. If I want 4 less than something, I start with x, my number, and I subtract 4 from it. This is the type thing we did on Delta Math. Or twice a number, right? A number is just x. Twice means 2 times, so this would be 2 times x. Okay. These are the types of things we did on Delta Math. The only thing we're changing now, instead of saying a number, right? Instead of saying a number, we're going to put a real unknown amount into the problem. Something like this. Jill's age is 4 less than Jack's age. Notice, this is the same problem. 4 less than a number, 4 less than Jack's age. All I did was stick a real value in there instead of just saying a number. Or Tom is twice as old as Jack. That is like twice a number, except instead of a number, I have Jack. Instead of a number, I have Jack's age. So it tells me I am supposed to write an expression to represent each of their ages. So in this case, instead of just a number, I have Jack's age. That is my x. And Jill, well, Jill is 4 less than Jack. Right? It's the same problem, except we're using real values instead of just saying a number. So Jill, if she's 4 less than Jack, she would be Jack's age minus 4, right? Or Tom is twice as old as Jack, so Tom would be 2 times Jack, 2 times X. I want to point out to you that these are the same problems as they were on Delta Math. All right, we're going to do some examples, and each of these examples was chosen for a reason, so I hope you'll listen to them and work through them with me. This first one is just the most basic type to get you used to what we're doing. Kelly has X dollars in her purse. So X represents the amount of dollars in Kelly's purse. All right, says it right there, I guess. X is a variable that represents some unknown amount, how much is in Kelly's purse. And now we're going to use X to represent other unknown amounts, right? That's what we're doing this entire time. We have a variable X represents some unknown amount, and we use that same variable based on how it compares to other amounts. For instance, Jimmy has $5 more than Kelly. Well, I know that Kelly is X. That's what X represents, how much Kelly has. So how much does Jimmy have if he has 5 more than her? Well, that would be the amount she has plus 5. That would be 5 more than her, right? Julie has twice as much as Kelly. So if Kelly is X and Julie is twice as much as Kelly, Julie would have 2X, right? And then finally, we're going to write a little expression for how much money do Kelly, Jimmy, and Julie have all together? Well, I know that Kelly has X. And I know that Jimmy has X plus 5. And I know that Julie has 2X. All right, I already got those amounts. So how much do they have all together would be those amounts added together. My expression for how much they have all together would be X plus 5 plus 2X. All right, all I did was add these 3 amounts together, and that would be how much they have all together. If I wanted to simplify that expression, which we probably would want you to simplify it, we would add the like terms together. That would be the X and the X and the 2X. And that would be, let's see, 1X plus 1X, that's 2, plus 2, that'd be 4X plus 5. And that'd be how much they have all together, right? All right, let's do the next example. All right, so in this example, I did not tell you what X represents. You have to choose. But I'm going to give you some advice on that. Typically, you would like to choose what X represents to be an unknown amount, always an unknown amount. But you want to choose the amount, well, let me show you. In this problem, we have 2 unknown amounts. The length of a rectangular play area, so I've got the length of a play area is 10 feet more than twice its width. So I have 2 unknown amounts, both the length and the width. Which one should I let my variable represent, the length or the width? Well, my strategy for this would be, I would have it be the width. I would let X equal the width. And the reason I chose the width is because I know how the length compares to the width. not the other way around. They told me how the length compares. They said the length is, and here's how it compares to the width. Bigger, it's bigger than the width, it's smaller than the width, whatever. Here's how the length compares to the width. So if I start with the width, then I can write an expression for how the length compares to it. So because, let's see, let me fill this in for you. Since we know how the length compares to the width, it would be easier to start with the width. And then I can write an expression for how the length compares to it. And let's do that. This is a tricky one, right? The length is 10 feet less than twice its width. All right. How do I get 10 feet less than something? To get 10 feet less than something, I need to subtract 10 from whatever. What am I subtracting 10 from? Less than twice the width. So if the width is x, twice the width would be 2 times x. And so this would be 10 feet less than twice the width. I'd start with twice the width, subtract 10 from it to get 10 less than it. And I have now represented the length. That's a tricky one. This is another tricky one that I want to make sure you have a nice example of. Let's see. So it says together Sam and Diane have $25. If Sam has X dollars, so I know that right now, Sam has X dollars, how could we represent the amount that Diane has? All right, this is a common problem. A common problem is you have two amounts that add up to something. In this case, they add up to $25. Together, they have $25. So if one of the amounts is X, how much is the other amount? And I don't know why this is on here, but I'm not using it anymore. But I want to kind of explain this to you. So, how much would Diane have? I think this is an easy way to think about it. Diane's part of the money would be the total amount minus the part Jack has. Oops, not Jack. I keep thinking Jack and Diane. What I really mean is Sam and Diane. Both are famous couples. I'll bet your parents would know who Jack and Diane and Sam and Diane are. All right. Anyway, so how much does Sam has? Sam has X. So Diane would have the $25 minus the part Sam has, right? Like if they had a bunch of $5 bills, right? And let's say that Jack has these two. Well, how much does Diane have? I keep saying Jack, I mean Sam. Let's say Sam has these two. How much does Diane have? Well, she has the amount that's left over. She has the $25 total minus the part Sam has. She has $15, right? Or if Sam has X dollars, then she has the total amount minus the part he has. She would have 25 minus X. Okay, this right here is how you always represent a total amount. you would always represent a total amount as X and total minus X. A little bit tricky. All right, we got, I think, 2 more quick ones here. 2 more quick ones and we're done. Too long. All right, Jake brings in cookies for a bake sale. Sally brings in 3 times as many cookies as Jake. That's an important sentence. 3 times as many as Jake. Let's just stop right there for a second. That's a little dangerous because you should probably read the whole problem. Mrs. Jones brings in 5 cookies less than Sally. I want to represent how many cookies each person brought in. All right, so the number of cookies Jake brought in. We don't know. Let's make it X. Now Sally is compared to Jake. She brings in 3 times as many cookies as Jake. So 3 times X. That would be 3X, right? And Mrs. Jones. Now this is tricky. Look, Mrs. Jones is not compared to Jake. Mrs. Jones is compared to Sally. 5 cookies less than Sally. So I need to take Sally's amount of cookies and subtract 5 from it. Sally is 3X. I want 5 less than that. So I would subtract 5 from it, and Mrs. Jones would bring in 3X minus 5 cookies. Last one. Bam. All right, this is a real situation. Talk Free, a new cell phone company, has an amazing offer. For just $5.95 each month, you get unlimited talk and text and pay only 2 cents for each minute of data use. That's pretty good. On the other hand, Sprint charges you only $1.95 each month for unlimited talk and text, but they charge you 5 cents per minute of data use. All right, so 2 real situations here. We got 2 cell phone companies. What do we want to do? What algebraic expression does each company use to calculate the cost each month for a customer? All right. So first I have to decide, what is my variable X going to represent? I want X to represent the amount that varies each month in the cost. All right? This does not vary. It always costs $5.95. Or for Sprint, it always costs $1.95. The amount that does vary is how many minutes of data use a person uses. That's the amount that varies when they calculate the cost of your cell phone bill. So I want X to represent that, minutes of data. That is what I'm going to have X represent. And then I need to write an expression. How much does Talk Free charge me? Well, they charge me, let's see, $5.95, and, which means plus, 2 cents for each minute of data. So $5.95 plus 0.02 times the number of minutes of data. This would be 2 cents for each minute of data, plus the $5.95. What about Sprint? How much does Sprint charge me? Sprint charges me $1.95. So they start out cheaper. I'm going to tell you next, but they charge 5 cents per minute. So a nickel, they add on to that 5 cents times the number of minutes I use. This would be my expression for how much Sprint charges for the cell phone usage. And this would be my expression for how much Talk Free chooses. All right, I hope you get it. Good luck on the homework. We'll see you tomorrow.